I was still a bit confused about the derivation section.
Yep.
So
Which equation?
mostly just how I can justify why I need the J term there, because it's necessary, but I feel like I need to justify it better.
Did you talk about the equation 10? Can you see here, equation 10?
Yeah, equation 10, that's the one.
Yeah. Well, this is to be frank, this is the first time I saw the Newton's law is written in terms of momentum flux. Okay.
Mm-hmm.
I think it's a little bit what do I call it, to draw the snake with legs.
Okay.
You don't have to, because Newton's law is so compact, like Einstein's relativity. It's just three variables: force, mass, and acceleration, right?
Yeah.
I think is something you need to explain that is you just probably at this stage, if you don't want to do from completely use my method, then you just explain to reader that J is a phenomenological momentum flux, okay? Because moment cannot be continuous. Oh, I tell you what, something I forgot to tell you in my edited draft. Don't consider this each cells in the CFD as a particle. It's not as a particle. It is because if you once you use Navier-Stokes equation, there's no pigeonhole, there's no place to incorporate molecular dynamics. Or in other words, you cannot consider atoms. That is one of limit of this CFD, Navier-Stokes equation. Do you understand?
I understand.
Because they treat that fluid as a continuous. Okay, there's no particle. There's no such thing as called quantum. In principle, they can increase this number as big as even infinity. Do you understand?
Yeah.
So that's why I think last year at a certain stage, I remind you that sometime you do need to incorporate molecular physics to describe the they call the molecular dynamics to describe the fluid, because after all, at the microscopic scale, right?
Yeah.
The interaction is not friction, okay? It's not what we call the fraction, the fraction. It is intermolecular interaction.
Yeah.
So that's why you have to forget about that what you call the frequent. I think I have deleted many of that. I think I have deleted that. So don't talk about frequent condition. There's no such condition. If you adapt, if you using Navier-Stokes equation, okay, there's no particle, no collision, but internal friction. That's all.
Okay. Yeah.
So I think if you don't want to go to use my method, then you just say that oh, I didn't notice, I didn't see any reference. That is something you need to fix it up. How many references have been used?
Oh yeah, I've got references. They should all be in there.
Why don't you to use the proper end note? For example, here in this particular case, that for example, if you want to get some, if you want to provide some explanation for equation 10, you just say according to reference what that Newton's law can be written as in this form. Okay, that's it.
Okay.
Okay. Well, tell people the reference. Okay. But in my opinion, so that's all. That's all. We don't have to expand that. But you know what? The idea, the key to derive equation is actually to consider the force separately, right? For example, after you consider that the so-called stress force, right, due to the contact, surface contact with adjacent cells, right? Then you have to consider, did you notice that in the edited draft, I added the pressure gradient related force?
Oh yeah, I saw that. Yeah.
Because that's something you have to mention that, because you just say, oh, that is a force, that is due to the pressure. You have to explain. Actually, the explanation is rather simple. Did you notice that? Because by definition, pressure is just the force divided by area. Okay, so therefore, if you just divide the volume, which is dx dy dx, right? Then you end up with gradients. Okay, you end up with gradients. That's why I use the Dow operator. Okay. Now another thing is that if you haven't got, so if you go to your equation 13, 14, 15, can you see that one?
Yeah.
So on the right hand side is the force, right?
Yeah.
But in the Navier-Stokes equation, every term must be dealing with a unit property. So in other words, both sides must be divided by volume. So you are lucky, you can see, if you divide the volume, delta x, delta y, delta z disappear.
Okay.
That is why how you jump from, that's how to, put this term, in this case, this is stress, right? It is tensors, right? You can construct, incorporate tensor into the Newton's second law, right? You can keep that. You can keep that from equation 16 to 20. You can, or even 25. Yeah, you can keep that. But just perhaps you just draw people's attention, right? Every term in the equation is dealing with property per volume. Okay, per unit, in the unit volume. That's why we didn't see mass. Instead we see density, right? That is why we see the pressure. We didn't see force. That's why, because that is a point property. Okay, so they dealing with the point property, but this point is not a mathematical point. It's a finite cubic, right? I think I noticed that it's a finite cubic, and it's far from mathematical point. But in principle, they can go as small as the size of cube can be as small as possible, even smaller than atoms. Of course, you don't have to discuss this idea, but bear in mind that is the case. All right.
Okay.
So actually, the CFD is not dealing with a real fluid in this regard, because there is no pigeonhole to incorporate molecules or atoms.
Got it.
So stop talking about collision. There's no collision. There's only friction, no collision. All right. So any other questions?
I'm just going through it, just through your notes as well. So one thing that I went to my teacher with this, with my last draft, and he had said that there are lots of terms that I need to define, like like what does it mean to have a steady state velocity distribution? Like here, so which kinds of terms do you think I should define for? Because I think that my referee won't have a good understanding of CFD.
Well, I show you what. I show you something. Hello, can you see the camera?
You might have just stopped sharing screen. I can't see.
Okay, I just stopped sharing screen. Where is how to return to how to stop the sharing?
If you just go back to Skype in your task.
Okay.
Stop sharing.
That's open there.
Oh no, just the two squares. Yeah, stop sharing.
Yeah, stop sharing. Okay. All right. Can you see my picture now? I hope.
I can see that.
Is that clear?
I can't quite read it, but.
Oh. Like this one? No? Can you see the
symbols?
Yeah. So this is my PhD thesis, by the way. This is my PhD thesis.
Okay.
So basically what I do is that because I use not of symbol here, I just put a list here. Greek symbols and the Roman symbols. Can you see?
Okay.
So why don't, instead of putting the obscure table in your in a page 1, page 2, or page 3, why don't you just prepare such a list at the beginning of this, or perhaps at just somewhere, so people can check, just like index. People can, when they saw some symbols, they can immediately find the definition.
So should I put it on the final page?
So final, you can put the final page, yes. But if this is you can put the final page. Well, you don't have to. You can put into the. It's not the book. It's not the thesis. What can we do? You can actually.
Appendix.
Appendix. Yeah, you put as appendix. Yeah, appendix. Just single page or two. Okay.
So in that, should I define words like velocity distribution and vorticity and stuff like that?
Basically, any symbol, on any notation you used, you will give it the alphabetical order, right? So people can, just like index of the textbook. So people can
only use symbols.
Yeah, use the symbols. Yeah, use the symbols. So for example, the including the dot and gradient, these vector field notations.
Okay. But the thing that my teacher wanted was I need to define words like velocity distribution, stuff that doesn't appear in a high school maths course. I need to define those words.
Yes.
Because teacher won't know what a steady state means or what pressure driven stuff like that. They won't know what that means. So
in that case, I don't think so. Your case is very special. I tell you what, if you have to confirm everything in the high school physics, that seems impossible.
Yeah, I agree.
You have to, because probably you are the only person choose this challenging subject, right? I think what you can do is that because we are dealing with high-level mathematics in this essay, right? We have no time to explain, for example, velocity field distribution, right? It's just, you can just say, I use that terminology in my edited draft, say we call the vector field. Okay, vector field distribution. Well, if the readers, like your teacher, found it hard to understand, we can't do anything. We can't do anything.
Okay.
We cannot translate that in a language of high school physics.
Okay, sure.
Don't worry, because if they were but you do. I think you don't make the gap. You do pair some intermediate, that intermediate explanation. For example, you will say f is what is the partial derivative. You do use some high school math and language there, right?
Okay.
Partial, people know the derivative. This called this delta represents the gradient. How to say the gradients. It could be what is not gradients? It's delta dot product. Vector, what's called that? Flux, what's called that?
Sorry?
What is the concept? I forgot. Divergence, right? Diverging?
I think so.
No. So what is that? Let's just go to there. All of a sudden. So you can talk about the dot product of two vectors, right? In this case, let's go back to, okay, that's at the beginning. We'll talk about the vector field. Where did you talk about vector field?
4.
Oh, here, okay, I saw that. Okay, that. Oh, yes, it's divergence. See, we saw divergence, div, right? Then then you can explain that this, this is you can treat the operator as the vector. You can treat divergence as dot product of dot product f, right? You can still use some high school level mathematics, right? But that's something you can do. Any other request from your teacher?
Actually, I'll run you through his feedback. Because I had a draft session with him. So he had mentioned the
Do they have written form? Is that in a written form?
No, it's just
in oral,
yeah.
Right? Okay.
So it said I need to reference the research question more, because that's one of the criteria.
Oh yes, yeah.
So I have to say, like, anytime I make like a big decision in the paper, I need to reference my research question.
Mm-hmm.
Do you think I've done that enough?
You do show that to what extent, right? And how and to what extent, right? That is the question, right?
Yeah.
Because you spend a lot of time to explain how, from how to build the equation, how to build this equation, and how to solve the equation, right? Either by analytic method or numeric method. So that will give you people's concrete understanding of how and to what extent. Okay. Now, if you do want to redress the question, you say, well, I think you have to. Do you have any place you can say something about the limit of this method? So this is not universal, okay? Because as I said, nowadays, people apart from use CFD, they also use the molecular dynamics modeling to dealing with real fluid such like a blood. Okay?
Yeah.
So in that way, you probably that's relevant to your research question. So probably you were in your conclusion, you just added one sentence that to say that eventually is understand that FD is not completely reliable, especially when you're dealing with real fluid. Okay. So the assumption are not is ideal, okay? Just like use ideal gas to start real gas, okay? So this is probably something you can say in your conclusion remark, that CFD is based on continuous distribution of the what called the puzzle, or called the elements, right? These so-called elements can be as small as 0, okay? Which doesn't make sense, because by the time you reach the size of molecule, some molecule, I remind you, in biology, like DNA, protein and DNA, is huge. Do you agree?
Yeah.
So they for millions of the atoms. In that case, how can you just still rely on these unlimited discretization, right? You can't.
Yeah.
You can't.
Okay.
So this is something you can mention in your remark, concluding remark.
Okay.
Anything new, anything you learn, or anything you found is interesting, you can talk about. You can, but give people. So the reason I rewrite a conclusion that the original conclusion doesn't say anything. Okay. About your achievement or the complexity, the process. You have to tell people what you have done, what you have achieved, okay? Even what you have learned, for example, because this is not a formal publication. So sometimes you can you can say, I do something, I feel something, I expect something. You can say so, all right?
Okay.
Okay. We don't want to make it too perfect. Do you understand? If it's too perfect, then that is not of the taste of the the author. The author is is high school students after all, right? Okay. So what other comment?
I'm just going through the paper.
You mean your paper, your draft?
So, yeah.
Can we just share my screen because your paper is on my screen now?
Okay. Yeah.
Okay, just share. Okay, we can go to any pages you want to go. So this is your paper, right? This is your.
Oh, that was another thing. So there are some places where he wants more explanation of what I'm doing in each step and linking
such
it.
As?
He said that the derivations isn't like my maths. It's something that other people have done before. So I need to link it to my problem, and I need to say how it links to the like the problem that I posed at the top to show why I'm deriving it in that way.
I don't agree. I don't agree. Okay. Think about the musician, all right? Now, if the 10 years boy can play Mozart, that means something. That means something. Do you agree?
Okay.
I mean, now the question, the form of the why the I think if you perhaps somewhere you have to make it more explicit that the Navier-Stokes equation is one of the most challenging questions in physics, right?
Yeah. Okay.
Now, if you for the year 12 student who spend on a few months, they know how to derive this equation. That's big deal. Okay. Not just because you see, that's how we study the relativity, that you can't say, well, Einstein have done it 100 years ago, then people are presumably can learn relativity. No, look at my students, so many questions about the relativity, they got lost all the time. I think you can just you don't have to accept it. You just say, well, that is one of the highlight of this research project. You understand?
Yeah.
So you can challenge that the people's stereotype. They say it's too early for you to learn. You probably have to learn these before you're trying to understand what this equation is. Do you understand? So actually, you have achieved that. It's remarkable. I can give you. I mean, I'm very frank. Okay, this is remarkable. It's remarkable. Even this has been done by many. Now, who can do original problem solving in the context of CFD? Ask yourself, ask him.
Yeah, you can't.
You can't. Okay, so that is not issue. I think you can still, but something you can do that you say, well, you agree, okay? You agree. You say, I will just trying to put some connection. Perhaps you want to draw some. I think another highlight in this essay is that you do demonstrate that even the CFD is very abstract and complicated, right? Still, you can find some essence from perspective of high school mathematics. Do you agree? For example, by the time you learn, so that's why I think you have achieved a lot. By the time you realize that the equation, the partial differential equation, can be solved by using the 4 rows. What is called a Euclid algebraic relation is just the linear equation. Okay, there's no square; it's linear simultaneous equation, and that's the breakthrough. Okay, because I think still many people still want to keep away from this treatment because they think mathematics is too complicated. But actually, I think somehow this idea, I think after, I hope, in the future, when they plan a new curriculum, idea from CFC can be taught at high school level.
Yeah.
Right. You don't have to go that far, but some basic idea can be told. For example, how to solve differential equation by use iteration. Okay, for example.
Mm-hmm.
Yeah.
Another thing that he had mentioned is, he said that because this is a mathematics paper, from section 8.2 till 10, I don't do any maths. So he was
It's
like,
just go to your content. Okay, I go to your content. From where?
8.2 onwards.
8.2, yeah. 8.2 is a CFD. It is the math. It is the math.
Yeah, so he wants me to do maths in that section.
Well, you do. How about 8.1?
Yeah, 8.1 is maths,
It is
but
a math. Yeah.
that's like some of the hardest maths I do.
Yes.
But he said I don't know. I didn't really agree because I thought like using the
I don't.
CFD software is quite.
Neither do I. Neither do I. Because you can't expect the students to do the original calculation in the field of the CFD.
Mm-hmm.
Because what you have tried, another thing I trying to draw your attention that using Excel to demonstrate how CFD work is very important.
Yeah.
Okay, so I think if you want to follow why don't you rewrite the title of this 8.2, right?
Mm-hmm.
After declaration, you will see that you could say implementation. You use the implementation of the CFD simulation.
Okay.
Because that give people something to say. Well, you just because you got that group number of the difference linear equation doesn't mean you can actually obtain the 2D or 3D diagram
Mm-hmm.
of the real of the distribution of the velocity or distribution of the pressure. You
Yeah.
agree? So
Mm.
discretization and implementations are, in my opinion, equally important.
Yeah. Okay.
It is a math. What else? It's computer math, It is math. If not math, what else? History, philosophy? No, it is
Yeah.
math. For example, by choosing, for example, in your discussing, actually, I try to improve your writing. That when you choose Excel, right, there is a gap between use Excel and the formula you obtained in your discretization section. You agree?
Mm.
The gap must be built by mathematics.
Yeah.
It is mathematics, in my opinion.
Yeah. I agree. Yeah. Okay. So I just wanted to make sure that like all the maths that I do is correct because I don't want anyone to like.
There's some part if you have time, and that is how to use the parameters. I double check that you somehow you can use the discharge coefficient. That's how to incorporate these C parameters into your block equation.
Yeah.
Now, it's not good mathematics at all. It's empirical or phenomenological approach to this
Okay.
issue. This is something because, for example, if you in principle you don't have to introduce this additional parameter. You just go to that. You just needed to obtain. You know the inlet velocity, right? The only
Yeah.
parameter is what you call the V2, right? You know V1. The only parameter you need in the block in the binomial equation is V2, right?
Yeah.
And there's no way. This is just energy conservation. Just give you one independent equation, right? You
Mm-hmm.
can't depend two unknown. That's the mathematical problem. Perhaps I suggest perhaps you take this opportunity to make some critique of this so-called calculation of the pressure drop using Bernoulli equation, right? It is impossible because Bernoulli equation is just the energy conservation law, different form of conservation law.
Right? Yeah.
And one equation can only solve one unknown. If you want to solve both pressure drop and the second velocity, it is impossible.
Yeah. Okay.
You just probably make some comment from this perspective. Okay. So therefore, but you see, the reason you choose either C, the coefficient, or even the Reynolds number is just disguised game. You see, I don't have to call it Reynolds disguise. I just got the V. Can you see?
Yeah.
You do need that V there. The V is unfortunately unknown. Therefore, people have to because that's my comment on your mathematics. That mathematics derivation there is not very good. It's not very good.
So should I just get rid of the discharge coefficient?
Well, you just say that if we can know independently know the V2, then we should be able to estimate the pressure drop. That's a period. That's period. Yeah. Anything beyond that is just cover up. All right.
So I can just get rid of it. I think I just did the calculation again.
Well, you see, another thing I have to remind you: Bernoulli equation and Navier-Stokes equation are not comparable. So don't put them together.
Okay.
Bernoulli equation for the steady state fluid is high school level physics. Okay, at the most undergraduate physics. All right.
Yeah.
Navier-Stokes equation is higher level. Okay, don't put them together. So that's why when you write the summary, you don't put these two equations together. Okay.
So what should I do with that section?
If I go to the which chapter? Which is chapter 7? No.
It should be chapter
7. Yeah, number
7.
9. Yeah. Let's go give you some remark because I don't have time now. Let's meet today because that's why I think it's. Let me see what is analytical solution. That is one. Oh, another thing is that I think I know now. The reason you didn't use polar coordinate is that you just want to looking for something different.
Yeah.
But unfortunately, if the referee are very careful, then he will find that this section is not good. Right?
What's that?
Because you see, you are trying to use Cartesian coordinates to solve the actually symmetrical fluid dynamics.
Mm-hmm.
So in the first place, the choice of coordinate is not wise. Okay.
Okay.
So eventually you can get that curve is correct, or you have to fix that integration. I think I pointed out yesterday. Yeah. So I regret. Why don't you keep use the polar coordinate or cylinder coordinate?
Like I can still change it, and it'll be easy to change. But
do you have time? Yeah. Yeah.
Do you think I should change it?
Or we just think that in this case you have to give the I don't know how much time do you have. You probably have to mention the form of the dot and dot operator in this coordinate. It's not the polar. It's called cylindrical.
Yeah, cylindrical.
Yeah, cylindrical coordinates. So if you have time, I don't know. I don't like because
every single thing
when we're due, I mean Wednesday is due. Wednesday morning or Wednesday afternoon or
Wednesday night. 12
Thursday
p.m.
night, 2 p.m. Or you have 2 days.
Oh.
You have 2 days, yeah. I suggest the priority, fix the text, please. First, fix the text first.
Mm-hmm.
All right. That will affect overall mark. All right. Okay. Now, if you have spare time and spend 2 hours, 3 hours to fix this particular, just replace this by the just replace this one, rewrite this section. Okay.
Okay.
Don't do it first, because otherwise you get nervous at the end. Any other question? Any question to edit feedback to my edited draft?
No, I think I just have to fix up the grammar and it should be okay.
Yeah.
And it's under the word limit, so that's good.
Well, that's easy. That's something easy for me to do. I mean, it's not, you know, when you write something, you have to make sure that you say something which is relevant, okay, which is relevant, and also you just build it. You just you know, put, you know, you see this just like a shop windows, okay, window dressing. You have to put things in the proper place, right? And other than just put, you know, into everything, or, you know, randomly, okay. Okay. So it's not a grammar issue. It's not a spelling issue. Everything, these two things can be done automatically. But what you need to pay attention, what you need to do is that actually to realize how to rewrite that draft in order to achieve your objectives. Communication, and also, you know, it's after all, this is a show off. This is just how, what you call your how to say. It's just, you know, for people to judge you, okay. So
I just don't want it to be like, because they really like it when you do like unique maths, which is easy to do in other topics. But I don't want them to mark me down because I've, like, all the maths is being copied from somewhere else.
Well, in that case, you don't have to solve that, and you don't have to give that analytical. You don't have to do that analytical. Well, of course, it's too sorry, it's too late. It's too late. Yeah.
But so, would you recommend either keeping it as it is in Cartesian coordinates and showing that I can do some of my own maths, or should I convert to polar coordinates and use someone else's maths?
A good question. And basically, there's only few cases, few special cases can people, you know, solve that. Can people find an analytical solution to the partial differential equations? But as good as exercise, I mean, because at the high school level, right? At the high school level, I think to solve a partial differential equation by using knowledge of calculus, that is quite relevant.
Okay.
Because I think that I keep that section, and if you have time, as I said, fix the text first, and then to replace that by polar coordinates, because that is a
okay.
Yeah. Doesn't matter. I mean, how people can argue you just repeat someone's work, but the reason is that you're not expect you to write everything original.
Okay.
Because the reason is that some people would not use this CF because something people, oh, they perhaps that people think that the question is not as complicated as if the equation can be solved analytically. But you probably just highlight that, you just point out, you just demonstrate that only on few occasions that this question can be solved analytically. Yeah.
I think the other thing, if I do it in polar coordinates, then I can have a 3-dimensional velocity distribution, which maybe.
Or don't do anything now at this stage. That's enough. I don't do more than what you have done.
But if I'm converting it, then the like the video that you sent me, where it has those polar coordinate solution, that's 3D. So when I graph it at the end, I'll get a 3D curve.
Well, you can just do. I think the how to say polar coordinate looks better. Okay. Because you can throughout this essays you always use the Cartesian coordinate, right? When you derive the formula, use Cartesian coordinate.
Okay, so I'll try and make the change. I should have enough time, because this is all I'm doing tomorrow. I'll try and make the change.
As I say, that fix the text first.
Yeah, I'll fix the text.
You can use otherwise you miss out the big issues. Right? It's up to you. I mean, I expect after the change, probably tomorrow you can send me your PDF and I'll give you a final remark. And otherwise there's not much time left, right? I tell you what, this side story, I know what you're using. That's what called LaTeX. Actually, that is a software I used in the 80s, right? In the late 80s, it was developed in 1980s. And but the reason I didn't use that now because I know that the Word can incorporate the formula.
Okay.
So you made a terrible, a bad choice this time. I'm sure you spend a lot of time to learn the how to type using LaTeX, right? This is not important. As a lesson, I think it's just in the future, don't pay attention to the format until you got the final draft. Okay, the final draft just make sure that every text is structure and of the grammar spelling is secondary, but make sure this text is ready. Okay. That's if you just I can't change the format, I can't do this, I can't do that. You waste a lot of time. Because if you input for example, another thing is that you don't approach people like me at the last moment. Okay. You need to go to stage by stage. You don't keep silent for 2 months or 1, and all of a sudden, tomorrow it's due. You need to I need 2 weeks. Okay, at this tempo. Then every time we can talk about not just the complicated problem, but also we'll pay attention to the draft. Okay. Do you know what? I eventually went to Shanghai to do advertising. The reason I can do that because I can write a better script than any others. Because customers are the giant multi-international companies, and they are working technologies, right? There are many issues, many demands. You want to put everything into the 5 minutes video. There are many constraints. So that is why, talk about this, my experience. I just tell you, the draft we finished is almost end of the draft. I still remember from draft 1 to draft 2 until draft 30 or something.
Yeah.
The draft is continuously evolving, okay? Refining and this kind of restructuring, okay? So this process is important. When you go to university doing some project, you have to pay attention to this. You have to be careful, all right?
Okay.
Don't do the formatting in the first place. It looks good dressing up, but so what? You see, if I didn't read, when the first time I received your draft, it looks like a paper. So what? If I read, you can see a lot of things to be refined or to be changed.
Okay.
That's some of my suggestion. But to handle your time properly, at the most you're going to have 2 days to go. Okay, don't go to the details now.
Mm-hmm.
Pay attention to the balance, the overall pictures. Okay.
Yeah.
Okay. I think if you follow my instruction yesterday, I think you can fix this most of the mathematical formula problem.
Okay.
Right. So I hope feedback.
Sorry.
If as I said in my email, if you could send me after you do the of your final outcome.
Okay, I'll send it. Yeah.
Something wrong with.
Well, the internet isn't really working.
Yeah, when you finish everything, when you finish the replacement checking or send as a PDF, I would remark tomorrow. Okay.
Sure.
Okay, good. Any other questions?
No, I think those are the main concerns. But thank you.
Yeah, just take it easy because you have done a lot of things. It's time to sum up. Okay, it's time to wrap. It's time to wrap this puzzle. Okay, or gift box. Yeah, you have to sometimes do some decoration, sometimes do clean up. Of course, it's absolutely important to minimize the mathematical errors in your essay. Okay, but don't spend too much time. Don't spend too much time now. You have balance your time.
Okay.
Okay.
Sure.
Read aloud after you got your final draft. Read aloud. Read to your dad. Read to your dad, or to make a communication, get some feedback. Okay.
Mm-hmm.
That is the way to. Don't just writing everything in silence. Okay. It is communication. You talk to people. Read aloud to see if any place to improve. All right. Because sometimes you have the unique constructed sentence. After you read that, or you realize, okay, how to improve that. Okay.
Yeah.
When you finish, you read to your parents, talk to them. Does that make sense? All right.
Yeah, that makes sense.
Okay. All right.
Okay. Thank you.
Yeah, welcome. I will expect to see your final draft. final draft. Okay. Take it easy. Take it easy.
Mm-hmm.
You have done a marvelous job. Okay. Goodbye.
Goodbye. Thank you.
You're welcome.